This project was actually a request from a 7-year-old grandson who sees his train set in the back here, and he wanted a mine pit shaft in it, but there wasn't enough room in the actual layout. And we saw one at the SECC, I think, a couple of years ago, where they actually showed it underneath, and this is what's in the back of his mind. So what I decided to do was make it like an add-on unit, and that's it there at the front, where we have the actual mine shaft, and that can be lifted off and put back on the side of his layout. And it's basically three sections. The top here we have the pit head in the winding, and then in the middle we have the pit shaft coming down with the 2 cages that run up and down, and then on the very bottom we have the underground bogies coming back and forward to the bottom of the pit shaft. So we'll start off with the underground bogies. And the original idea that I thought was have a piece of end gauge rail going back and forward along there, and have a small locomotive on it which should be powered from the rails. But this was going to prove to be expensive to buy an end gauge locomotive to go in there, because everything I've got is O gauge. And I ended up printed the rails and printed the 2 bogies and the small electric loco at the front there. And to make it go back and forward, I decided to use like a cable, like the Clockwork Orange goes around Glasgow. You use a cable to pull it back and forth. And that is actually a fishing wire that's on there to do that. And it would be driven from a motor. And that motor would be like the back and forth that you have, the MERG has down there, and use a pit controller. And that was David kindly provided me with a pit controller and the program in there, because I'm not into programming, or haven't been. And we had the 293 controller to control the motor. And the motor here is a DC motor which came out an old printer. It's very much overrated, as you can see the size of it, but it got it out a printer and it works. And here we have the resistors and some of the wiring for it, but from the IR detectors on this side and on this side here. So that the small truck basically just goes back and forward all the time. This is underneath it, and here we have the cable or the fishing wires running along here, and it goes through the gearing and it just gets pulled back and forward and back and forward. Seems a bit complicated, but it's just all made out of the gears that I had from the printer, and I've got a 3D printer, so I made the casings here to hold it together. So the cages going up and down, everything was all 3D printed, the cages and the supports, the guides for them. And these are controlled by the Arduino Nano. And the initial position is detected when you trip the infrared detector at the bottom. The top and bottom positions are then determined by the number of steps in the stepping motor, because the stepping motor is driven to drive the cages up and down. They also put in sounds from the BBC. I managed to download sound effects for that, so that when they go up and down you get the sound effects as well. But the big thing, and we had this debate down at Prestwick, is how the whole thing starts up when you put on the power, because I had 1 or 2 disasters when it pulled over everything and pulled it out because the motor just kept running. So what I ended up doing was the cage where the infrared detector is would just be raised very slightly up the way. So if it was down at the bottom, it would just come up clear of the detector. But if it was equally so, if it was at the top, it wouldn't get pulled right out the mine. So after it came up, it would then be lowered until it came down and triggered the infrared detector. Now, because I'd built the detector into the mouldings, it stopped at the wrong place. And what I had to then do was change the software so that once it triggered the detector, it then moved a certain number of turns till it reached the starting position. And that was the whole thing then ready to start its sequence of going through the up and down. At the top, the stepping motor here, which is driven by the Arduino, and we have the winding here, the winding drum, and they ended up having to split the winding drum in the middle, because as one is pulled up, the other one is let down. And to get them balanced, you really need one side adjusted. So rather than trying to adjust the length of the rope and the loops and different things, this half here of the winding drum it slides there, so you can actually slacken the screw and just turn it very slightly, and you can adjust the position of it. The pit head here, the top, I got that from the internet. I trawled the internet and found different places. You could actually buy a kit, but I just took the dimensions that were shown on the internet and just drew it up in Tinkercad and printed it all off. The most difficult part was actually printing the wheels, because you've got all the spokes, so there's quite a lot of supports had to be broken off while I did that. The box itself, that's based on just its A4 plywood sheets, which are just, you can cut with a Stanley knife, just piece them together and glue it all together. So that's how the top was constructed. Now, to control the cages going up and down, used Arduino Uno, and you needed a voltage regulator there for that to give us the 5 volts for the IR reflectors. The LEDs was putting on the whole thing, and the DF player. They also had the H bridge had to be controlled for the stepper motor. Put all this together, and this is the breadboard for doing it. And as you can see, I've used the DIY standard colouring sequence, which is basically just use any wire you can get your hands on. So it was a bit of a mess, and I was thinking of doing it in Beiro board, but I decided as I actually do PCB design, I designed a board for it. And this is the schematics drawn up for the PCB, for the nano and the LEDs, and driving the stepper motor and the voltage regulators. And that's basically the board, the outline of the board there, where we have the buck units for changing the voltage down from 12 volts going in down to whatever we need for the stepper motor or driving the rest of the board. The IR detectors, 2 connections, so you can have the IR detector, which I used, or the 3-pin one, which the module, which is actually much easier to set up, and the DF player and the module. The module can be fitted on here, or you can populate the component to drive the stepper motors. So that was a finished PCB, and I think most people have seen that already. And this is an assembled board here. And in the actual mine itself, it sits here just above. In the bottom here, we have the small trucks going back and forward, and then in this space is all the electronics for driving it with the speaker. what I finished up with. I've had that down at Prestwick, and that's what's now installed in my grandson's layout. With all the things that David brings along every second Friday, it gives you new ideas on what to do. So I decided to do a Mark II version, and I would change the optical sensors to the actual modules, which is easier to position. And instead of the small carts going back and forward, I decided to put in a conveyor belt system. So you have a conveyor belt going along, and here to load a cart, and the cart would be pulled out from the cage and then pushed back in and then go back up the mine shaft. So I think I actually went to there, didn't it? That's it. This is underneath, just to show you the mechanisms here. On the top left here we have, if you just see there's a red circle in there, is like a small triangle, and that's a lever that goes back and forth, and there's a small pin in it as well. And the idea is when the cage comes down, it gets lowered onto that, and they can pull the truck out underneath the hopper, and it'll go back in again. And that small linear lever there, it runs, it's like a lead screw we have here mounted onto a servo motor, which I converted from being a servo motor to just a DC motor, and used the small micro switches that David supplied at each end, so that it will just run from here and go back, and the micro switches stop it, and if it goes forward, the micro switches stop it again, and that just goes back and forth. There's quite a lot of work had to go into this to make sure I got the right helix, otherwise it just more or less just sheared the pin off rather than moving it along. And also this orange area here at the other side of it is a dead stop for the cage. So when the cage comes down, although the stepping motor stops, there's just a fraction of a millimetre still out to just touch there and stop. Otherwise, if the floor of the cage is not exactly level with the floor of where the hopper is, it can catch and get pulled out at quite an acute angle and cause big problems. So this is the Mark II version here. I haven't got the stays on it yet, because sometimes when things go wrong, this tower starts to get pulled over. And so we've got this along the bottom here with the conveyor and the electronics in here for driving the stepper motor, and also I populated the other site, and I'm driving two DC motors, one for the conveyor belt and one for driving the cart out and in. So there's two there. And also added here is the OLEDs on the side, so that as it's going up and down, these small indicators travel down and travel back. Go up and down. And of course, I just used another board to put the nano in to drive the OLEDs. And I've started to make structures up here. This is like the small winding house, and that was printed in the 3D printer. And as John Fogarty said, it's easier to print it in sections and glue it all together than trying to print it all in a one. And that's even the case on I changed the way I printed the top of the structure here for the top where the winding wheels are, because the railings before were all printed together with the top. But I found actually if I print the railings separately and then glue them on, it's much more robust than trying to print them onto it all in one. So that's where I'm with that. I've now got two OLEDs on it, one at the top and one at the bottom. And next stage is to add in more LEDs to illuminate different areas of it. So that's where I am at the moment.